Today we are going to learn binary search trees. So the main difference between binary trees and binary search tree is that in binary search tree, the elements on the left of the root node are always smaller than the data value of the root, and the elements on the right of the root node are always greater than the data element of the root. So in insertion and deletion there will be major changes, and this is the graph that mostly we use along with AVL, which we'll see in the next video. So let's come to the coding part. Now I'll tell in the starting create node function everything is same, but in insert node and delete node there will be minor changes. And this might look slight different from what we did in the binary tree, but this is also valid. You can try any of the method, both will work perfectly. So now we come to the insertion important part. There is okay, so this color was looking quite off, so I thought there is something off about this. So it was a semicolon issue. Now into insert. This is quite different, so carefully. First we'll check if root is null. We'll just return and do the create node thing like we did in the here. So but now we have to check the condition that if the data element that we are going to insert is less than the root. If it is less, it will come in the left. If it is greater, it will come in the right. So we'll just type that out. If data is less than root dot data, then root dot left will be updated to insert, and it will be called recursively. Right? If we just copy paste this for the we can change it to greater, and instead of root dot left it will be root dot right. This video will be quite long, so we'll return the unchanged root here. I hope it is pretty simple in the insertion part. We need a traversal which will just take from the binary tree, but I think I'll show you the traversal first and then we'll type out the deletion code. You can also take these values as input. So we'll be creating this tree only, this tree. Okay. So I'll just copy it for a couple of times. This would be 30. I'm just writing random things because I know the graph. If there is a different graph, you can obviously change it. So this will create, and then we'll call our this was how we called the in order. Now we'll just copy the in order traversal. You can check how it is different from the insertion in simple binary tree. Let's see. Okay, there seems to be some issue here. Yeah. So there was one issue with that. I was not returning anything in the create node function, and my function was a node star type pointer, so I have to return a value. It wasn't a void, and there was a little bit of warning that I was not returning here also. So rest all is perfectly working. It is, if we check the in-order traversal of this tree, it would obviously be first will come to 20, then 30, then 40, 20, 30, 40, then we'll come to 50, 60. After 50 we'll travel to 60, then 70, and then 80. So it's coming perfectly. So insertion is all done. Now we have to make the code of deletion. So deletion is quite long. For that, first we need a function to find the minimum value. And what can be the minimum value of a binary search tree where left is always smaller? So the minimum value would be the leftmost subtree of the whole tree. So we'll just try to find that. Let's just call it more. Yeah. So there will be a while loop because we have to check that if there is a left pointer or not every time. So I will just name it C instead of current. So the while loop will be C and C dot left not equal to null ptr. So this C means that C should be present. It shouldn't be an empty, like current value shouldn't be empty, this thing. And we'll update the C to the left subtree of that. It is quite simple code actually. And then we are going to make the deletion code. It will be quite long, so I'm not going to make a separate video on that. It will be in single one only. If root is null ptr, we can just, so one thing is that if it is a single line output, you can just type space and this will also work. You don't have to make these brackets. This will work perfectly. And then we are going to delete a node. Check where is the node first. So this is similar to the insertion, just we are calling deletion, and we'll specify the deletion code in the else part of that. And we are going to make it for root.write. Okay, now we have reached to the data, right? Now we have to delete it. For that we are going to write else. So else, there are many different parts I will show in here. So consider if I have to delete 20, I can just take this out and take this. So 20 is no longer connected or in the graph. It is similarly simple because we can just delete free the space and it is deleted. But if we have to delete 30, so what would come in this place, the empty place? So it can either be 20 because the right of this node is greater, or it can be 40 because the left of this node is smaller. So it can be anything. We are going to check first with the node that has only one child. Like if it has only one child and we have to delete 30, we'll just delete 30 and store the 20 in a temporary variable and connect 20 to the 50. It would work perfectly. And in the last part, in the end, we'll check this condition where there are two children. So I'll just write here node for only one child or no child. It is similar because for one child we'll store this and we'll check first if there is left pointer or right pointer. If there are, let me just write the code, you will understand it perfectly. If root dot left is null, then we'll store we'll make a temporary variable and store root dot right in that. Okay, we have to delete the root and then we'll do delete root and we'll return temp here. You got this? if we just copy it and paste it here and check for root dot write, here we'll just do else if root dot write is null ptr, we are going to store temp. In temp we are going to store root dot left. We'll delete the root and return the temp. Okay, but if there are two children, this will work for one children and two children both. Okay, but if there are two children, we have to first make a similar temp. Temp won't create any problem because here it is defined inside the else if and if, so it doesn't have any effect outside. So first we'll find the min value. Why we'll find the min value, I'll tell in a sec. So in here, like I told you, we would replace it with 20 or 30, 20 or 40. So in here we are going with 40. If you want to replace it with 20, in this part you just write root dot left. Okay, if you write root dot left, 20 will come in this place where my cursor is. If you follow me, it can depend on the type of question you have. 40 will come here. Okay, so we reach to the 40th now. Or if in case we have to, let's say, delete 50, so we reach to 60, because the next lowest on the root dot right of 50 is 60. If we went to backwards, 40 would come and replace 50, because on the left of 40, 30 and 20 are there, which are less, and on the right of 40, everything is bigger than 40. Okay, we would update. So what this line does actually is, now that temp has reached to the value which we want to replace it with, we'll just update the root data to the temp data, so that if we go to the way I have written, 60 will come here. Okay, and then we have to you got this line? So like we are recursively calling it now. Now we have put 60 on the top by this method. So now root dot write, we are updating the root dot write and calling delete node function recursively, so that it checks root dot write and temp dot data. Okay, and in the end, after all this, we'll just return root. Right, now I'll just call the delete node function. Let's say I want to delete, let's just first, let's say I want to delete 20. Okay, delete node and root comma 20, and then we'll get this. See, 20 is deleted, and the in-order traversal is just starting from 30, then 40, then 50. because left is not there. In order it is left data and left root and right. So this way. And if we went to the, like in here, this thing is not affecting because it is only for one child. I shall write here node for two children. Okay, so now if I try to delete, let's say 30, so according to the code, what would be the in order reversal? If we are replacing 40 with 30, this is going and this is coming here. So first it would be 20, 40, 50, 60, 70, 80. Let's try this. See, 20, 40, 50, 60, 70, 80. I hope you can see it. I'll just pull it up. See here. 20, 40, 50, 60, 70, 80. Because we are changing it from the right value, larger value. If we change it from the smaller value, we have to change here to root dot left, and here also, here also. So this would be 20, 40, 50, 60, 70. Yeah. And if we try to delete 50, so it would be replaced by 60. See, you can try this on your own. Tell me if you find any error. There is also another function which I seem to have missed. Yeah, there are some type of questions in which we have to check if a data is present in the binary search tree or not. So we'll just make a search function. It would have a return type. Let's just let's just keep key as the name of the value we have to find. If root is null, then we don't have to find. Or if root dot data is already key, then we can just return root. It would be easy for us. But if root dot data is less than that of the key, that means that key is greater. We have to search on the right. So root dot, we have to recursively call root dot right and pass the key. We have to do the same thing, but you can just write this here. If this works, then it is fine, else do this. Okay, let's just try it. I have written search node root, and let's find 70. So we can't find it right that. We can make a variable of node star type and write f as name, indicating found or not. So if f is not equal to null ptr, that means it has a value. We can just see out that 70 is found in this tree, else we can see out 70 is not found in this tree. Okay, where is the line? So 70 is found in the tree. If we try to search something that isn't, like we have deleted 50, let's try to find 50 and update here 50 and 50. 50 is not found in the tree. So these functions and these questions are only that you are going to receive in the exams. And even if you are learning for some other purposes, or you want to just learn DSA, this is the most like basic codes. I'm not using any other different libraries that we have, just IOStream. Thank you for listening.